So what we want to look at today is we want to get ourselves set to get into the trig. And trig is really, there's two misconceptions about trig. The first misconception is that trig is about triangles, and it's not. Trig is about a circle and parts of a circle. The second big deal about trig is all about to get from that circle to right triangles, it's all about similar triangles. If I have a triangle, and let's just make it a right triangle for now. So I have two right triangles. If I know that this angle here, and I'm just going to label it angle A, is the same as that angle, I know that those are similar triangles. Everybody's saying, well, how can I only know one angle and know that they're similar? Well, I actually know two because I know the right angle as well. Right angles have to be equal to each other. If those two angles are equal to each other, remember that in a triangle, the angles must add up to 180. So if two out of the three angles are equal, the third one must be equal as well. So all three angles are equal. And if all three angles are equal, they are similar. One must be an enlargement or a reduction of the other. So then if I were to tell you that this here is 16 inches and down here is 10 inches and 8 inches, and we come over here and I tell you this is 40 inches, we can find these other dimensions, x and y, because of the similar triangles. Remember, we find the two sides that correspond to each other that we know the lengths. That's the 16 and the 40. Doesn't matter whether I do 16 over 40 or 40 over 16. If I'm looking for x, where's x going to go? Bottom, because it's from the same triangle as the 40. What's going to go above it? The 10, because that's the corresponding side of the other triangle. So we'll cross multiply and divide, and that gives us, what, 25 for x? So we end up with that length for x. To find y, we do the same thing. We still have the 16 over 40. Where's y going to go, top or bottom? Still bottom. Still from the same triangle as the 40. What goes above it? The 8 is the corresponding side of the other triangle. And we cross multiply and divide. 8 times 40 divided by 16 is 20. So y is 20 inches. So pretty basic here. We've also looked at dealing with triangles. If we know the sides are proportional, then the angles must be equal. Let's say I say that this is 4 inches, 10 inches, and 12 inches. If this is 8 inches, 20 inches, and 24 inches. Because those sides are proportional, these sides here are just double those sides, right? This angle has to equal this one. This angle has to equal this one. And this angle has to equal that one. Because they're between what we call the corresponding sides. So if we don't know anything about the angles, but we do know the ratio of sides is the same for every corresponding pair of sides, they must be similar. Now we said we're going to work with circles. That trig is about circles. So let's work our way up to some of our definitions here, and we'll work our way up to circles. It may seem a little bit unusual. We're going to talk about something called polygons. A polygon is a figure that has a set number of sides. So we can classify polygons by their sides. And it's usually by the number of sides. A three-sided polygon is called a triangle. Four-sided? Quadrilateral, yep. 5 is a pentagon. 6, hexagon. 7, heptagon. Sometimes also called a septagon. 8, octagon. 9, nonagon. 10 is a decagon. 11 would be undecagon, 12 would be dodecagon, tridecagon, and then there's a special. Really, for you guys, I have seen 10 and 12-sided figures in construction, but you're going to be dealing mostly with hexagons and octagons. Octagons are relatively common. We can classify polygons by their angles. Convex polygons versus concave polygons. A convex polygon is one where all of the angles are set so that each vertex technically creates two angles. Like this vertex here has an angle here and an angle out here, right? A convex polygon is set so that all the smaller angles are on the inside. A concave polygon might look like this. At least one of the angles is set so the smaller angle, one of the vertices, is set so that the smaller angle is on the outside. For the most part, you're going to be looking at regular polygons in construction. Regular has two qualifications. Qualification 1, equilateral. What's equilateral mean? Equal sides. Equilateral, though, is not enough to mean regular because that has all 6 sides the same, but it's not regular. So the second qualification for regular is equiangular. In other words, equal angles. Again, that's not enough alone to be regular, because I could have all those angles are the same, but it's just one set of sides is stretched out or whatever. If I'd drawn that well, all the angles would be the same at least. So to be regular, it has to be both equilateral and equiangular. So in other words, all sides are equal, all angles are equal to be regular. And if it's regular, we can deal with the angle sum. Did I show you where the 180 comes from for triangles? Okay. Let's look at this. Here's a triangle, right? If I start out traveling along the triangle here, right? I get here and I turn. I'm going to label this angle D. My triangle is going to be angles A, B, and C. So now I'm traveling down this side. I get here and I turn. I'm going to call this angle E. So now I'm traveling this way. I get to this corner and I turn here. I call that angle F. Now I'm heading back in the direction I started. So if I add up these 3 angles here, D, E, and F, what do they have to add to? Careful. I made a complete 360-degree turn. So D plus E plus F has to be 360. What do these two have to add up to? 180. So that's 180. What do these two have to add up to? 180. What do these two have to add up to? 180. Well, that adds up to 540 degrees total, right? But from that, I'm going to subtract the D, E, and F, which is a total of 360, right? Leaving me with 180 degrees. A plus B plus C will always add up to 180 degrees, no matter what shape the triangle is. What that amounts to here is, you'll notice I've had 1, 2, 3 180s. That's just my number of quarters. So n times 180, or 180 times n. And I subtracted 360 degrees from it. That gave me the 180 here. For any figure, though, that's my angle sum. Now, a lot of textbooks, they simplify this formula. Rather than saying take the number of angles times 180 and then subtract 360, they divide out the 180 to make it look like this. If I multiplied through by the 180, I would get this. But it's simpler to take the number of angles, or the number of sides, it'll be the same, minus 2 and then times 180. So if I have a pentagon, for a pentagon, n equals what? How many sides does a pentagon have? 5. So the angle sum for a pentagon is 180 times 5 minus 2. Well, 5 minus 2 is 3. 180 times 3 is 540. So a pentagon has 540 degrees angle sum. You'll recall we talked about in triangles, we talked about isosceles triangles, where two sides are the same. Of course, one of the things then, what do we know about these two angles? They had to be the same as well, because remember we said the largest side is opposite the largest angle, and the largest angle is opposite the largest side. Well, if those two sides are the same, they have to be opposite the same angle. And some of the things we had mentioned about it is something called a median. What's a median? If I drew a median from here, what does it do? It splits the other side in half, right? That's called a median. But in an isosceles triangle, a median is the same as an angle bisector. So it cuts this here into two equal pieces. It also cuts this angle into two equal pieces. And a median or an angle bisector is also an altitude in an isosceles triangle. So that means is that it hits this at a right angle over here. That's going to be important once we get to circles and some of the rules about circles. So we've talked about triangles in depth already. Let's talk a little bit more about quadrilaterals. Now, a quadrilateral is just any four-sided figure. There's a quadrilateral. Nothing really special about it. But we can start out with some special quadrilaterals. A parallelogram. A parallelogram, opposite sides are parallel to each other. So that's a parallelogram because this side's parallel to this side, that side's parallel to that side. A consequence of this is that the opposite sides will be equal. Those two sides will be equal. Those two sides will be equal length. Now there's two different paths we can take here from a parallelogram. The first path is something called a rhombus. A rhombus is a parallelogram where all four sides are equal. So we can go and you can keep the angles, but we make all the sides equal. Now in these parallelograms, by the way, one consequence we should state. Because these are parallel lines, I can think of this side here as being a transversal. What do I know about this angle and this angle? They have to add up to 180. Because this angle and this one have to be the same, don't they? And then these two make a straight line. So those two have to add up to 180. So these two add up to 180. They're supplementary. So that means if I know this angle, let's say I know this is 70 degrees, this angle has to be 110. Now the second path we can take from a parallelogram would be a rectangle. There's still two different lengths of sides. This side's equal to that side, and this side's equal to that side. The difference between it is it's got the qualification that the corners are right angles now. It still qualifies as a parallelogram because opposite sides are still parallel. It's just now all of the angles are right angles. The opposite sides are, adjacent sides are perpendicular to each other in a rectangle. Then these two come together to make a square. A square can be thought of as a rhombus with right angles, or it can be thought of as a rectangle with equal sides. All of these are parallelograms. A rhombus is a parallelogram, a rectangle is a parallelogram, a square is a parallelogram. So if I ask you, if I have these four shapes sitting there and ask you to identify which ones are parallelograms, they all are. If I ask you to identify which ones qualify as a rhombus, obviously this one does. The square does as well. If I ask you which ones qualify as a rectangle, of course that one does, and the square does as well. So this is a square, but it's a rhombus, a rectangle, and a parallelogram. There is a type of regular quadrilateral or special quadrilateral that is not a parallelogram. That's a trapezoid. The definition of a trapezoid is a figure that has one set of sides that's parallel. So there's a trapezoid. This side's parallel to that side. Or it might look, that's a trapezoid. This side's parallel to that side. What we want to look at is what's called an isosceles trapezoid. An isosceles trapezoid, this side's equal to that side, that angle's equal to that angle. An isosceles trapezoid is symmetrical. If you cut it here or fold it across that yellow line, it would fold on top of itself. Now, in any trapezoid, there is something called a median. In a triangle, you remember that median went from a vertex to the center of the opposite side. In a trapezoid, the median connects the centers of the non-parallel sides. So here, these are the two sides that are not parallel. Here's the center of that one. Here's the center of that one. There's the median. Same here. Center, center, and there it goes. Same here. Center to center, like that. The median will always be parallel to the bases. The two sides that are parallel to each other are called bases. So it'll always be parallel to the bases. And its length will be the average of the bases. Remember we talked about this when we were finding the area of trapezoids last semester? Average of the bases times the height. Basically, it's the median times the height. So if I have a trapezoid, let's say this is 12 inches here, this is 30 inches. I construct my median here. How long is my median? Inches. I add them together and I divide by 2. Any questions? In your big book, page 514 to 516, I do 1 through 10. This is going to be in the unit exercises. Then on page 528, (1 through 24) is also in the unit exercises. A lot of review, that's why we skipped right to the unit exercises instead of doing each individual section. So I have you work on those for a little while, then we do have a quiz coming.